Hello, welcome again for your next class, that is mathematics. 10th September, the date is same, today's date, and the class for today is mathematics. In mathematics, in the last class we were discussing trigonometry, and I was just going through the new reduced syllabus for 2021. Here we have got only two sections given there. That means in the textbook, if you look at the unit 21.5 and unit 21.6, it is there in your page number 327. These two topics in the unit, that is 21.5, you have got trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles, and second one is using your trigonometric tables. So these two unit or exercise is what you call, that is 21C and 21D. These two units have been excluded, and you have got only the first section which we have done, that trigonometric identities, using the square identities like sine square theta plus cos square theta equals to 1. Then you have got sec square theta minus tan square theta equals to 1. Then you have got the cosec square theta minus cot square theta equals to 1. So using that identities and some other algebraic formula, we have already proved some ICSE questions as well. So I think that is one section you will get, and the second section will be your heights and distances. So these two are excluded for the time being, so no need to do this exercises. So we will straight away go to heights and distances. Today I'll just give you a brief introduction on heights and distances, and from the next class I'll be solving the problems. Basically, heights and distances it is the practical use of the trigonometric ratios that we have learned. It is the practical applications of the trigonometric ratios in order to calculate the heights and distances of various objects which we cannot actually measure them. Like for example, if you want to find the height of a tree, it is practically very difficult to climb up and find the height of the tree. Or if you want to find the width of a river, between the two banks, or maybe you want to find the height of the mountain, all these heights and the distances are practically very difficult. You cannot measure them in actual. So we make use of this concept, the terms heights and distances. It is the practical application of trigonometric ratios. So in order to find the heights and distances of various objects, we have to understand two terms here. The first term is, there will be two things here, that is the observer and the object. Okay, so these are the 2 points you need to understand. Observer is, for example, let us take one example. You have a tree here, alright, and this is the ground, and you are there. You are observing, you are seeing, so you become the observer. Let us say point A. You are the observer. So observer is, you take that point from where you are trying to see some objects. These objects you can see in two positions. Either you see one position is above the point of observation, and one is below the point of observation. So when you observe this above, suppose you see a bird on the top of a tree, so you are observing above. That means it is elevation. You are then observing with respect to this horizontal line. Suppose this is the horizontal line, this is the observer, and this becomes your object. For example, this is a lake here, and below the lake you see a fish, suppose a lake or a pond, whatever is there, and you see one more object. Let us say it is a fish here. Then you are observing down. When you are observing up, it is elevation. When you are observing down, it is depression. So these are the two important points to understand heights and distances. Only these two angles you have to learn. So in order to do a quick recap, how to find the heights and distances with the help of the trigonometry, we have two things here, the two terms, observer and the object. Observer is that who is observing. Okay, so point of observation. For example, if I take me to be observer, so my eye is the point of observation. So from the eye, first of all comes the horizontal line. So with respect to that horizontal line, you will see either up, suppose I am seeing up there, that is elevation, or you are seeing below, that is depression. So you have got two angles here, that is angle of elevation and angle of depression. So first angle comes the angle of elevation. Angle of elevation. These two angles are very, very important. In the angle of elevation, observer is always below the position of object. Observer is below the position of object. For example, point O is the observer. So from the observer, you have to first of all draw this horizontal line. Okay, that is very, very important. And let us say A is the object, and from the observer you will make one angle. So this is called the line of sight. So this angle which is made here, angle is made by the observer looking at the object with the help of this horizontal line. So this angle is called the angle of elevation. Elevation means you are rising. Okay, so this is the line of sight. So this is the what you call horizontal line or x-axis. Similarly, you have the angle of depression. In the angle of depression number 2, depression means looking down. Observer is above the position of the object. So let us take O is the observer, and always you have to draw this horizontal line. Okay, now with respect to this, you are looking down, object is here. So this angle is called the angle of depression. So in the heights and distances, it is quite simple. There will be a word problem given to you. You have to read that question and you have to deduce the diagram. There will be at the most 2 diagrams, and that diagram will be drawn on the basis of this idea or the knowledge of object, observer, angle of elevation and angle of depression. So in the next class we will be dealing with this some problems. I will be taking some ICSE problems and also some questions from the textbook. Thank you very much.